Okay, and today we're going to focus on our last way to solve quadratics, which is by completing the square. So I'm going to do this first example as I kind of read through these directions because the directions don't necessarily make a ton of sense unless you're doing a problem. Okay, so first we're going to make sure that the coefficient of the squared term is 1. So I see that it is 1, but if it was not, then we would divide that equation by whatever the coefficient is. And we'll have some examples like that over here. But our coefficient is 1. Now we want to move the constant term to the right-hand side of the equation. Okay, now remember our constant term is the term without a variable. So I'm going to go ahead, I'm going to write x squared minus 4x. Now, when I do these problems, I always write myself this plus blank, and I will explain that in just a second. So when I'm kind of setting them up, when I move that constant over, I give myself a plus blank on both sides. And the reason we need it on both sides is because that additive property of equality, that if I do something to one side, I have to do it to the other side in order for them to stay equal. Okay, now let me tell you where we're going. So remember last week, we talked a little bit about this pattern of a trinomial that's a perfect square trinomial. So we see that this factors into a binomial squared every time. And so kind of the pattern that you're looking for is that the first term is a perfect square and the last term is a perfect square, and that this middle term is twice the product of the first and last terms. And so it's always going to factor into this a plus b squared binomial. So that is kind of what we're doing. We're trying to kind of make, on the left side, we're trying to create a perfect square trinomial so that it will factor into a binomial squared. Okay, so to do that, we take half of the coefficient on the x term. Okay, so I'm going to go over here and say, okay, what is 1/2? And it is -4. 1/2 of -4 is -2. And then it says, step number 4 says, square the result of step 3. So we got a -2, so then we square that and we get 4. So then we are going to add that to both sides. So this is where I put my plus blanks in. I'm going to add that 4 to both sides. Now, the entire reason that we just went through all of these steps is because this gives us a trinomial that is in this binomial squared pattern. So we always, when we're doing completing the squared, we know that from whatever we do here, we are coming down into a binomial squared. So what is the binomial squared? Well, we know that the way we get x squared is to have an x at the beginning, and then whatever the number that was half of that b term that you squared to put here, that's what's going to go inside your parentheses. So that's kind of why I write out these steps, because then I say, okay, that's what goes there. And then I say, okay, I've got 18 plus 4 is 22. And so now the reason that we do this is because this is like one of those square root binomials a perfect square binomial. So we can just take the square root of each side. So I'm going to take the square root of the left side and take the square root of the right side. That square root undoes the square. So I have x minus 2 is equal to, and then remember, every time we take a square root in order to solve a problem, we have to give the plus or minus. So plus or minus the square root of 22. Now, we always want to check to see if this can be broken down anymore, but I know the factors are 2 and 11, and neither one of those are perfect squares, so this one isn't going to simplify anymore. But the last step I need to do is move my 2 over, so I have x is equal to 2 plus or minus the square root of 22. So we can see it looks kind of like one of those quadratic formula solutions, but this would be our solution. And if we wanted to like graph it or something like that, we could just put in our calculator 2 plus the square root of 22 and 2 minus the square root of 22, to get our 2 points that we could plot. Okay, next one, we're going to follow that same pattern. So this one, my constant is already on the right side. So I'm going to go ahead and write out my y squared plus 8y plus blank is equal to 10 plus blank. Okay, and I'm going to go down here. I've got some room down here. I'm going to take, okay, what is 1/2 of that middle term? 1/2 of 8 is 4, and then 4 squared is 16. So this is the number that's going to get added to both sides. So 16 and 16. Now again, the purpose of doing that is because every single time it will be a binomial squared. So we know that we've got y at the front. We see our signs are positive. They're the same and they're positive. And then what was the number that we plug in? Whatever was half of that middle term, or 4, the number that we squared. So y plus 4 is equal to 26. Okay, and again, I have a perfect square binomial, so I could take the square root of it to undo it. And then I have y plus 4 is equal to plus or minus the square root of 26. So again, we want to think about 26. Does it simplify? Well, it's 2 and 13, and neither one of those simplify. So we're going to just subtract our 4 to get y alone. So I have y is equal to -4 plus or minus the square root of 26. Okay, now remember step 1 said that we have to get rid of a coefficient if there is one on the squared term. So here I can see that there's a 2 in front of my squared term. Fortunately, all the other ones are also divisible by 2. So if we divide 1 by 2, we have to divide them all by 2. So then I have a squared plus 8a, and then again, I'm going to give myself a plus blank is equal to 2 plus blank. Well, we just did this one, right? We know what the numbers should be. Half of 8 is 4. 4 squared is 16. So we're adding 16 to both sides. Okay, the whole reason that we do that is because we're going to get that binomial squared. Here our variable is a. The number that we squared to go here was 4, so that's what goes in with my binomial. And then I have 2 plus 16 is 18. Okay, square root. I get a plus 4 is equal to plus or minus. And then I want to think, okay, 18. Well, 18 does have a perfect square factor. It's 9 and 2. So the square root of 9 would be 3. And then we would just leave the 2 underneath. Last step, move our 4 over by subtracting. So a would be equal to -4 plus or minus 3 root 2. All right, moving on. Okay, again, we see there's a coefficient on the squared term, so we're going to divide everything by that. Fortunately, again, they're all divisible by 3. So now I have x squared plus 2x minus 4 is equal to 0. So I need to move my constant over. X squared plus 2x. I'm going to go ahead and give myself my plus blank. I move my 4 over so it's positive on the right side, and then I give myself a plus blank. So I need to figure out what is half of 2. Half of 2 is 1. 1 squared is 1. So we're adding 1 to both sides. And then we know that that is going to factor us into that binomial squared. So I have x plus, what was the number we squared? 1 is equal to 5. So we take the square root of both sides. X plus 1 is equal to plus or minus the square root of 5, and then subtract our 1. -1 plus or minus root 5. Okay, last example. Again, we see we have that coefficient. We're going to go ahead and divide everything by 2. So we have x squared plus 6x, and again, I'm going to give myself the plus blank space. My constant is already over on the right-hand side, so I can just simplify and give it a plus blank. So now I need to figure out what is half of 6. Half of 6 is 3. 3 squared is 9. 9 is what gets added to both sides. Then we go straight into that binomial squared. So we know we have an x plus, and then what was it that we squared? We squared the 3, so the 3 goes in there, and I simplify my terms on the right side. 11 plus 9 is 20, and then we take the square root of both sides. So x plus 3 is equal to the plus or minus. All right, square root of 20. I know that there's a perfect square of 4 and a 5. So a perfect square root of 4 would be 2, and then the 5 is going to just stay underneath the radical. And then I subtract my 3 from both sides, so x is equal to negative 3 plus or minus 2 root 5. All right, and those are examples about completing the square. So what I want you to notice is that, again, we are creating that perfect square trinomial every time so that we can always go to that binomial squared. So if you can kind of just remember the step that you're going to do a plus blank on both sides, and then immediately after that step, you're going to go into a binomial squared step so that you can square root both sides. Okay, I want to kind of wrap up all of our notes about the solving quadratics and kind of give you some of our best case, like, okay, here's when you use this. So factoring. You can use factoring. It's best when either there's no C term, because then you would just factor out a GCF, and that would be easy to factor, or whenever your expression is easily factorable. Okay, if we can think really quickly, you know, what are the numbers that multiply to give me 3, that add to give me 4, then we just, put them in our factors, and then remember, it's always our roots are the opposite sign of whatever is in our binomial factors. So if we had a plus 3 in the parentheses, it's our solution is a minus 3. If we have a plus 1, then it's a minus 1. So again, factoring is useful when they're easy to factor trinomials, or again, when there's no C, so that you can just kind of factor out a GCF. All right, square roots. When do you use square roots? Well, we only use square roots when when like at least one of the sides is a perfect square. So if I have like a binomial squared, or if I just have an x squared on one side, I can take the square root of both sides. Remember, whenever you are solving a problem and using a square root to undo something, you have to give yourself the plus and minus roots. And then remember, if you're taking a square root, you always make sure that the right side, if you can simplify it, you do. Excuse me. Like in this case, we see that a 24 is a 4 and a 6. So the square root of 4 is 2. And then that 6 just stays under. And then we bring our 5 over. All right, when do we complete the square? Completing the square is good for whenever A is 1, and also when B is an even number. I don't know if you noticed on all of our examples that every time we gave you one, we gave you where B was an even number. Because if B is not an even number, then you're ending up, you know, with, let's say if this was 5, it'd be 5 over 2, and you'd be squaring 5 over 2 squared. So it's not really helpful unless that B is an even number. But again, we notice that we just keep our constant term over. We take half of that middle term. We square it and add it to both sides. And then we know that that gets us that binomial squared. And then we just simplify it like it's a square root problem. All right, and then when to use quadratic formula? We use quadratic formula when the numbers in our, as our coefficients or our constants are kind of larger numbers. Whenever the numbers, whenever something doesn't easily factor or we can't easily identify the factors, quadratic formula works every single time. Now, there are things to kind of look out for quadratic formula. Plugging in signs appropriately is important. Making sure you reduce when you can. But quadratic formula works every time as long as you have kind of a formula or an equation in standard form. You can always use quadratic formula. But we usually want you to either complete the square or factor, or look for those, you know, if those are possible first before you start using quadratic formula. But in a case like where we have 5 and -7 and -8, those are kind of bigger numbers. We don't necessarily see that they would factor, so quadratic formula is the best way to go. So I hope this has rounded out the quadratic solving quadratics for you and kind of giving you all the information in one place for you to kind of figure out what works best for you.